Okay, this is section 4.4. Today we're going to be talking about slope, and before we get into the full-blown lesson, I kind of want to review something that you should have picked up in middle school at some point in time, whether you've had algebra, pre-algebra, whatever. You've probably talked about slope before. So go ahead and get your paper out. It doesn't need to be graph paper tonight per se. It can be either type, really doesn't matter. And you don't need to draw this picture. You can do a brief sketch if you want to, but I want you to take a look at this and try to figure out what the slope is. And if you remember, just to give you a brief reminder, slope, we use the variable m. It's a lowercase m, and that stands for the slope of a line. And there's kind of a famous formula, I hope you're familiar with it. We define slope, one of the ways we define it is as the rise over the run. So if you remember this, go ahead and do rise over run for this red line graph and tell me what the slope of this line is. So go ahead and hit pause now, and then unpause when you're ready to go over. And maybe if you're not sure, you can think about it for a minute or so and then unpause. All right, go ahead and hit pause now. All right, let's see what we came up with. When you want to find the slope of a line, you need to really have 2 points on that line in mind. And one of these points they kind of gave to us, this 0, 3 up here. So I'm going to kind of focus in on that point. And then you need to pick another good point, that is a point that maybe crosses at a whole number coordinate. So there are a couple of these on the board. I'm going to focus in on this guy right here. You can see right there at that intersection, it crosses over the graph paper at a perfect corner. So I know I'm going to have whole numbers in my coordinate. Okay. All right, so if we know that slope is rise over run, let's start with the rise. So we're going to start at this bottom point, and we're going to rise vertically all the way until we reach the level of our next point. And so really, I'm trying to hit this ceiling right up there. And the question is, how far did I rise? If you had to count with your fingers how many hash marks up the graph I went, how far did I go up? And if you count those, you're going to get 4. So my rise was 4. And I'm going to put that over my run. Okay, so the rise is sort of like the vertical component. The run is kind of like the horizontal component. And so continuing where I left off, I'm going to see how far I move over to get to that second point. And basically, it's that distance between here on the left and here on the right. So how far did I move over with that distance? And if you count the hash marks there, we're talking about a run of 2. Okay, so slope is defined as rise over run. My rise was 4, my run was 2. So what is 4 over 2? Well, it's the number 2. So we say that for this graph, I have a slope of 2. And the purpose of today's lesson is for that 2, what I'll call the slope number, I want that 2 to mean something to you. In other words, that number actually describes a couple different things about this graph. It's going to tell me if it's going up or down, positive or negative. It's also going to tell me if it's steep or gradual. So by the end of this lesson, I want you to be able to have a vision of what some of these slopes are like, depending on what their slope numbers are. Okay. The other preview here is I'm going to refer to a roller coaster when I talk about slope. Okay, so this is kind of like the roller coaster I have in my head. A couple things I want to say about it. When we read the roller coaster, we're going to start on the left. So we always read slope from left to right. Okay, so we're starting over here on the left, and we end on the right. So just know that the roller coaster always goes from left to right. Okay, let's take a look at how this roller coaster would begin, specifically with this section right here. Okay, if we're reading this left to right, do you think that that slope is positive or negative? Well, it's going up, and up is associated with positive. Okay, so that is a positive slope. Now, would you define this, or would you describe this as steep or gradual? Most of us would probably go with steep. That first section of the roller coaster there is going up, it's positive, and it's also steep. Okay, take a look at this next section. Do you think that that slope is positive or negative? Okay, well, they're definitely going down here. That's negative. From left to right, we're going down, so it's a negative slope. Now, steep or gradual? Well, this guy is also steep. So notice that positive and negative have no bearing on whether or not something is steep or gradual. It can be either. Okay? Also want you to notice that there's this kind of peculiar point right up here at the top where just for a brief nanosecond, you're neither going up nor are you going down. Your motion for a brief nanosecond is almost horizontal. Okay? It's neither positive or negative. We'll kind of come back to that. You also hit another point like that right about here on your way down, okay, where the change ends up going from negative back to positive. So here we have another positive slope. Now, this guy would you describe as steep or gradual? Well, this one's definitely a little bit more gradual. And once again, we get another one of these changeover points. Okay, and after that point, our slope is going to look something like this. Positive or negative. Well, this guy's negative. He's going down the roller coaster. And he's also gradual. And so when we look at the graph of a line, I'm going to want you to imagine like where this thing would fall on the roller coaster. Is it going up or down? Is it positive or negative? Is it steep or gradual? And the numbers are going to match up with those concepts, okay? And this is just something I've given you. It's not going to be in a textbook or anything, but according to me, what I consider to be steep, a steep slope will have a slope number where the magnitude of that number, the absolute magnitude, is going to be greater than 1. So whether it's on the positive side or the negative side of the number line, we're looking for something with an absolute magnitude bigger than 1. For example, a slope number of 2 means you're going to be steep, okay? A slope number of 3 means it's going to be a steep line. We can also have the negative sides of those. Negative 2 is going to be steep. Negative 3 is going to be steep. Any number bigger than 1, basically, or a greater magnitude than negative 1, okay? So it could be like negative 7. It could be 8. It can even be a fraction as long as that fraction is bigger than 1. For example, 5 over 2. Okay, that's 2.5. So remember, fractions don't always mean small. A fraction bigger than 1 is also going to have a steep slope. Gradual slopes, on the other hand, are going to be fractions less than 1. Okay, so for example, 1/2. That's a gradual slope. 1/3. That's going to be a gradual slope. Negative 1/2 would also be a gradual slope. Negative 2/3, also a gradual slope. Basically, any fraction, positive or negative, it's going to have absolute magnitude less than 1. Okay, so when you see a slope number, you should start to maybe even picture in your head what that graph might look like. Okay, and this is going to kind of mess with your head even when you're walking around town or you're out in nature. You might start thinking about slopes now mathematically. For example, this guy right here, okay, I would characterize that as positive and gradual, opposed to this guy right here. He is negative and kind of steep, or even like this side of the tree over here is negative and very steep, whereas this side is positive and very steep. Or even this branch down here is negative and gradual. Okay, so just sort of a way of describing lines. All right, now let's get into the math. Okay, so in elementary school at some point in time, hopefully you talked about slope being rise over run, and that's kind of where we begin. So just to review, m is the variable we will use to represent slope. Okay, rise over run is usually the first way we think about it. Okay, this is when we have a picture of a graph and we're able to kind of count with our fingers how much it's going up, how much it's going over. The problem with rise over run is when you get into fractions and decimals, you can't count with your finger. You need a more precise way of doing it. Also, you're not always going to have a picture. Okay, so you can't always rely on rise over run, but there is a formula that will work all of the time. Okay, so let's delve deeper into rise and run. What is rise? Well, rise is pretty much the change in the y component. Okay, if you look at this picture right here, all right, the rise would be, if I started here and wanted to end here, how much do I change vertically as I move up? So the change in this y all the way up to this y. And to find that change, basically we're trying to find the difference of those two y coordinates. That's why you'll see over here, to find the change in y, we're going to find the difference of the two y values. And in math, difference is the exact same thing as distance. You want to find the distance between 2 points, subtract them. Okay, difference is distance. And we'll look at the same thing for the x. Okay, to find the change in x, okay, change in x, we basically want to know how our x coordinate is changing from here to here. What is the difference in those two x coordinates? Well, the difference in those two x coordinates will tell us the distance between those 2 points. So we want to find how far this is from one point to another, then we subtract the two x coordinates, and it's going to give us that distance. So the formula for slope today, if you haven't learned it before, is going to be one of these two guys over here. M will equal, okay, the difference of the y's over the difference of the x's. And notice there are two versions of this formula. In one of the formulas, you begin with the second y coordinate and you subtract the first y coordinate. And as long as you set it up that way, you have to stay consistent with the x's. You'll start with the second x coordinate and the first x, subtract the first x. Or you can start with the first y component. And if you start with the first y, you'll have to stay consistent all the way throughout and begin with the first x as well. Okay, let me show you what I'm talking about. This is pretty easy. If you've done it before, this looks familiar, and if not, maybe you're freaking out a little bit right now, but I promise you it's not that hard. Okay, so you have your slope on your paper from the very first example. All right, now we're going to start some other examples where instead of counting with your fingers, you're going to be figuring out the slope using the slope formula. And this first one I'm going to walk you through. Okay, so go ahead and get your paper back out and ready. It says find the slope of the line passing through -3, 0 and -1, 6. Okay, here is the formula we are talking about. We will say that slope, m, equals y sub 2 minus y sub 1. Okay, that's the difference in the y values. That's the rise, over x sub 2 minus x sub 1. And that's the difference in the x values, or the change in x. Where am I getting these numbers from? Well, they've given us two coordinates. It's kind of like you have 2 points on the line. And before we get into any of the math, we need to label these guys. So come over here to -3, 0. Now this -3, is it an x coordinate or is it a y coordinate? Well, you know that. It's an x coordinate. Okay? It's actually our first x coordinate. So we will label it x sub 1. Okay, now this 0 right beside of it, it's a y coordinate. We will label it y sub 1. Since this is the second ordered pair over here, these will be our sub 2's. So -1, we will just label x sub 2, and +6 we'll label y sub 2. And these are the values you're going to plug into the formula. In this first one, I want to get you set up. So what I always do next is I'll write down m equals, I draw my fraction bar, because I know I'm going to be dividing, and then I will actually draw in the minus signs as part of the formula. Always draw in those minus signs regardless. You don't want to start doing work ahead in your head, simplifying minus a negative. You're going to get some double negatives from time to time, no big deal. but don't try to do it in your head. Write it down first and then interpret it. Okay, so let's look at y sub 2. Okay, what number are we going to plug in here for y sub 2? Well, y sub 2 is this guy right here. It's the positive 6. So in the y sub 2 spot, we plug in a 6. Okay, y sub 1 is 0, if you look at that first ordered pair. X sub 2 is negative 1, and x sub 1 is negative 3. So that's how you should have this set up. And then basically you're just going to crunch those numbers. Okay, and if you want to get a head start on me, feel free. On top, for 6 minus 0, you should have 6. Now on bottom, be very careful with your integers. Negative 1 minus negative 3. Minus negative 3 is going to be plus 3, so negative 1 plus 3 is positive 2. Okay, so what we get is a slope of 6 over 2. 6 up, 2 over. 6 up, 2 over. That's a rise of 6 and a run of 2. And that simplifies to a slope number of 3. Okay, so here m equals 3. Okay, now you'll notice what I've said down here. It makes no difference which point you designate as x sub 1, y sub 1, as long as you keep it consistent. In other words, we could do this exact same formula, but reverse the y's and the x's. Okay, or I'm sorry, we can reverse the y sub 1 and the y sub 2. Y's will always go on top, x's will always go on bottom, but those orders of the y's and x's can be reversed as long as you keep it consistent. Okay, so I want to show you this. We could have written y sub 1 minus y sub 2 over x sub 1 minus x sub 2. This is what I do. I'm a y1er. Some people are y2ers. They're going to do the first problem. I always do it with y1 beginning first. That's the way you'll see me do it in class. I want you to write this down with me so you can just follow along with me, and the next ones I'll let you do by yourself. Okay, y sub 1 is 0, y sub 2 is 6, x sub 1 is negative 3, and x sub 2 is negative 1. I just want to show you that we should end up with the same answer. Okay, so 0 minus 6 is negative 6. Negative 3 minus negative 1, that's negative 3 plus 1. It's going to be negative 2. And a negative divided by a negative is going to give me a positive. So even here, m equals 3. Point is, you can do it either way. You should end up with a positive 3 no matter what. Okay, so our slope number is a positive 3. What does that tell us about our line? Well, 3 is positive. Do positive numbers go up the roller coaster or down the roller coaster? They're going to go up. So we're going to have positive slope here. This guy's going to be going up the roller coaster, positive slope. Is it going to be steep or gradual? Well, according to that dichotomy I gave you earlier, a number bigger than 1, like 3, is going to be steep. So I can expect this line to be going up, and I can expect it to be pretty steep. And this would be an example of what I'm talking about. So it's going to tell you that positive slope rises to the right, as long as you're reading it from left to right. I like to think of it in terms of the roller coaster. So this is a slope of 3. Okay, it's up 3 over 1, up 3 over 1, up 3 over 1. And you can see if we had our roller coaster, it would fit in something like this. Okay, going up steeply, and it is positive. Okay, all right, so moving left to right, positive is going to be going up the roller coaster. Okay, this next one I'm going to want you to do on your own. And remember, you don't need graph paper here. You're just going to be using the formula. Okay, so it says find the slope of the line passing through negative 2 comma 1 and 1 comma negative 3. I want you to write down your slope formula. You can either start with y2 or start with y sub 1, whatever floats your boat. Go ahead and crank it out and see what slope number you come up with. Okay, so do that on your own. I want you to go ahead and hit pause now, and then we can reconvene to go over answers when you're ready. Okay, before I go over this, you can actually see the graph below. Okay, take a look at your slope number that you came up with. Is it positive or negative? Okay, and which one should it be? Because this graph, this line, it's going down. So your slope number should be negative. Steep or gradual, this one's kind of in between. So I'm going to tell you this, it's going to be a number close to either 1 or -1. Okay, let's get into it and see what we come up with. First thing you always write on your paper, and this is something that you need to have in your notes. Slope formula, m equals y sub 1 minus y sub 2 all over the change in x, x sub 1 minus x sub 2. We're subtracting those coordinates to find distances. Okay, I need to go back and label. This is x sub 1, this is y sub 1, and this is x sub 2 and y sub 2. The most common mistake is that people are just going to put things in the wrong places. And you're going to do this at some point in time. Don't feel bad, everyone does it. Just make sure that your y's are always on top and your x's are always on bottom. Okay, y sub 1 for me is 1. Y sub 2 for me was -3. Now you could have done it the other way with y2. You should still end up with the right answer as long as you're consistent. X sub 1 is -2 and x sub 2 is 1. Okay, and I'm going to crunch those numbers. 1 minus -3 is 1 plus 3. I get 4 on top. And then -2 minus 1, that's type 1 subtraction. Get mugged twice. I'm going to lose 3. What is that number? That number is an expression of -4/3. So I like having that negative in there because the negative tells me that I'm going down the roller coaster, and this guy is definitely going down the roller coaster. So that matches up. The 4/3, technically it's steep. Okay, so this would be a negative, slightly steep line. So hopefully you came up with -4/3 as well. And it's going to tell you here that negative slope falls to the right. You already know that. We're just going to say that it's going down the roller coaster. Okay, next one. Find the slope of the line passing through -1, -3 and 5, -3. So you'll need to put this one down on your paper as well. Go ahead and get started on your own. See what you come up with, try to interpret it, and then unpause when you're ready. We'll go over answers. All right, let's see what we come up with here. I'm going to go ahead and label my coordinates first. That's actually usually what I do when I'm working on my own. So this is x sub 1, y sub 1. This is x sub 2, y sub 2. Always begin by writing down my formula. So slope equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2. And you might be getting pretty tired of me saying that by now, but I'm trying to model this for you guys. If you want to be good at algebra, any kind of higher level math, it requires patience and kind of being systematic about your work. And I hope you're buying into that by now. It's going to make you stronger students in junior and senior year math. All right, let's see what we come up with. My y sub 1 is -3, it looks like. And my y sub 2 is also -3. My x sub 1 is -1, and my x sub 2 is 5. Okay, be very careful with these integers up here. -3 minus -3 is -3 plus 3. That is 0 on top. -1 minus 5 is -6 on the bottom. And if you're a y2er, I think you came up with 0 over +6. Doesn't matter if it's 0 over -6 or 0 over +6. What number are we talking about? Okay, the answer is 0. Okay, 0 over anything is 0. So our slope is 0. What do you think that means? Well, it's not positive, it's not negative, it's not going up, it's not going down. Okay, it's kind of like that point at the top and bottom of the roller coaster where things evened out. A slope of 0 is going to be a horizontal line. Okay, slope of 0 is a horizontal line. And this actually is our line. And just to do a very quick review, let's see if you remember what the equation for this line is. For a horizontal line, remember it was y equals a number. Which one would this be? Y equals what? Well, it comes all the way down here and crosses the y-axis at 3. And actually all of these points have a y coordinate of 3. That's why the name of the line is y equals 3. Now let's connect that to what we're doing. I'm sorry, not 3. Negative 3. We're below the x-axis. Y equals negative 3. Okay, connect that to what we're doing. Take a look at the ordered pairs. This y-coordinate is negative 3. This y-coordinate is also negative 3. Any point on this line is going to have a y-coordinate of negative 3. And that's why the name of the equation is y equals negative 3. Okay, and hopefully you remember that. All right, we got a couple more examples. I want you to go ahead and try this one on your own as well. So the last one was a slope of 0, and we got a horizontal line. Okay, a little foreshadowing for this one. Find the slope of the line passing through 3, negative 1 and 3, 4. Go ahead and try this one on your own using the slope formula, and then unpause when you're ready to go over answers. Go ahead and hit pause now. All right, let's see how we did. Always begin by labeling your ordered pairs. I'm going to be using the formula. Slope equals change in the y's, that's your rise, over the change in the x's, and that's your run. Now, a curious thing happens in this one as well, and I just want to see if you're able to interpret it. Okay, my y sub 1 for this one is negative 1. My y sub 2 is 4. My x sub 1 is 3, and my x sub 2 is 3. And when you crunch those numbers, you end up with negative 5 over 0. Okay, now, if you did it as a y sub 2, or maybe you get positive 5 over 0, but the big thing is 0 is in the denominator. Is that the same thing as the number 0? No, it is not. When you have 0 in the numerator, that's 0. When you have 0 in the denominator, what do we call that? Well, it's illegal in mathematics. Okay, we call that undefined. So this slope is going to be undefined. Okay, what does an undefined slope look like? Well, you probably guessed this. If it's a slope of 0, it's a horizontal line. If it's an undefined slope, what type of line do you think it is? Well, it's going to be a vertical line. Okay, if the slope is undefined, the graph is a vertical line. And this one, we could write the equation for this. Hopefully you remember how to do that. Vertical lines have the equation x equals a number. And for this vertical line, it would be x equals what? Well, it comes all the way over here to 3 on the x-axis. So x equals 3. Because all of the points on this line share something in common. They all have x-coordinates of 3. Even the 2 points we were talking about have x-coordinates of 3. And that's what makes it a vertical line. Okay, so undefined slopes will be vertical. All right, so just to kind of sum up what we did today, positive slope will rise to the right, meaning it will go up the roller coaster. Might be steep, might be gradual, but it will be going up. Negative slope falls to the right, so that means it goes down the roller coaster. Might be steep, might be gradual, but it's going to be going down. A horizontal line has a slope of 0. So for a horizontal line, the slope is 0. And then a vertical line is what we get when we have undefined slope. Okay, now I'm going to go ahead and stop there. There's a little bit more to the slideshow, but maybe we'll get to it in class. I think that's enough to get you going. And this might be a good resource for you to come back and use it to study. And I will tell you that you do need to have that slope formula memorized, not just for the test, but it's something you're going to be using every year while you're at Brophy. So make sure you not only memorize it, but that it makes sense to you as the change in y over the change in x. All right, good job with this, and good luck on the assignment.